Good day, everyone. Welcome to Math World. I am John Jesus, the mini Einstein. Today we'll be solving various questions on bearing and distance. I just want you to pay maximum attention because this is the part that students hate the most, and I will make this part very easy to understand. Now, there are some things that we have to tell you before we start solving questions on it. The thing I will tell you is that whenever you are drawing, you want to do bearing and distance, it's actually going to lead to triangle. Triangle. So it can either be right angle triangle or it can be normal triangle. We have different types of triangle, isosceles, scaling, different types of triangle like that. So I will just list the formula that you will need to be using when you want to solve bearing and distance if it results in triangle. Number one formula is Pythagoras theorem. Okay, Pythagoras theorem states that hypotenuse square equals to opposite square plus adjacent square. But how do we know hypotenuse, opposite and adjacent? That is the challenge for students. Some students will say that the longest side of a triangle is the hypotenuse. Yes, you are right, but you are not truly right, because if they should invert this triangle, you'll be looking for the longest side, which you will find difficult. But the main thing is that wherever you see the sharp edge, it has a sharp corner here, so that is 90 degrees, no doubt. Others can be like this or can be like this also here. So wherever you see this sharp edge, where it is pointing is the hypotenuse, and it is surely the longest side. So where this sharp edge is pointing is actually the longest side. I will still discuss more of this when we enter trigonometry. Where this angle given to you, maybe you were given theta here, the angle given to you here, the opposite to this angle is what we call opposite side. Now if it is this side that was given to you, here will be opposite, note that. But if this place was given, this is opposite to this angle, and the other part will be the adjacent to this angle. Do you understand? That's how you use this. But if it is normal triangle, this is right angle triangle. If it is normal triangle, let's assume this is capital letter A for angle A. This is capital letter B for angle B. This is capital letter C for angle C. Where this angle A is facing is small letter A, we call it side A. And where this capital letter B is facing is what we call side B, which is small letter b. And where this C is facing is what we call side C, where small letter is facing. Although there is a lot of method whereby we prove how the formula was being given. But if you want that, you can comment in the section below. So the first rule that you need is cosine rule. What does it say? It said that if you are looking for this A, it means that A squared equals to B squared plus C squared minus 2BC cos A. If you were given A, or you are looking for A anyhow, but here you are going to, they will give you 3 sides and 1 angle, which means maybe you are looking for 1 side out of the 3 sides and you were given 1 angle, or you were looking for the angle and you were given 3 sides. No, this one actually talks about ordinary side, and if you want to look for angle of this one, we use what we call SOHCAHTOA, which I will discuss after this guy. So if you were now given 1 angle and 2 sides, looking for 1 side, you use SOHCAHTOA. If it is B you are looking for, it's still the same rule, you just change the value that is here. That's how you do for cosine rule. But if it is sine rule actually talks about sides and angle. It talks about 2 angles and 2 sides. Remember, this one talks about 3 sides and 1 angle only. This sine rule talks about 2 angles and 2 sides. So it says that this is what sine rule talk about. Sine A, this is A over small letter A, equals to sine B, this is B over small letter b, and sine C. So if you were given sine this place and this place, and you are looking for maybe A and you were given this place, you just actually plug in your value. You can say sine A equals to sine B, and use it as one formula. You can say sine B equals to sine C and use it as one formula. You can say sine A is equal to sine B. I mean sine A over A is equals to sine C over C. That's what I meant. So you can actually use it like that. So you can take 2. Remember, it's only 2 you can take out of this guy, and you can use it. And the last one which I talked about is SOHCAHTOA. This S stand for sine. So it means sine theta, if you are looking for this theta, equals to this opposite over hypotenuse, this hypotenuse. The second one is C, which is cos theta equals to adjacent over hypotenuse. And the last one is tan, which is tan theta equals to opposite over adjacent. That is the formula that you need to know for now before we start solving this. So it's now depend on which triangle you get that will now tell you which formula to use in all this. Now let's go to the question and see what we can do. The question says point P and Q respectively 24 meter north and 7 meter east point R. Now you know I told you that whenever you want to solve bearing, I said it in my reverse bearing, that if they say that from, you are drawing that one first. And if you should read this question, we are talking about this R, that this point P is 24 meter from R. This point Q is 7 meter east from R. That's what they mean. So they said point P and Q respectively 24 meter north and 7 meter east point R. Now let me draw point R and see. Remember, you start from the middle, you don't start from edge. So let me start from the middle like this. Remember, this is our north, our south, our east, and our west for point R. They now say that point P is 24 meter north point R. They did not give you any degree here. If they had given you degree, you will have checked the degree. But they said north of R, which means it goes straight. They can say that due east, due west, due north. If they say due anything, it means you are going straight. Maybe due north, going straight upward. Due east, you are going straight eastward. Due south, you are going straight southward. And due west also, like that. So here they say that point P 24 meter north of R. Let's now draw that one. We draw this one up. Let me stop here because of space, so I can now draw my point R. So I can say this point P that is from R. But how many degree meter? They said 24 meter. Please be precise, as I told you. And they said point Q is 7 meter east of point R. I'm not going to draw E as long as this R. Remember, this R, this P is 24. So I'm not going to draw my Q as long as this P. Now I will just draw it going like this because they said east point R. So I will just stop here so that it won't look complicated. So I will just draw my north, south, east here, and I put point Q here. Now you have formed it. So this is the only thing they will tell you. So you now find your ruler and join these two lines together. Just make sure you place your ruler at the middle of these points, this where the cardinal points meet, and here also where the cardinal points meet. So you just use the ruler to match them together. Once you draw a straight line, you see it has actually formed a straight line. But which type of triangle does it form? Is it right angle triangle or normal triangle? And if you should look at it very well, remember, right angle triangle, what specifies right angle triangle is that it has a right angle, and right angle means 90 degree, which is this sharp edge. So this sharp edge is 90 degree. So here now we can say that between north and east is 90 degree, which means here is 90 degree. It is a right angle triangle. I told you in my videos that I've done, in my previous video that I've done, that whenever the angle between north and east is what? Is 90 degree. You can see now is 90 degree. So it is a right angle triangle. Let's now go to the question. The question says, what is the bearing of Q? They ask for bearing, they don't ask for distance. The distance is this. The bearing is the angle. Remember what I told you is the angle position of a point from another point. So they said, what is the bearing of Q from P? Okay, from P, we are reading from P. Of Q is this guy. We want to read from this guy. Do you understand now? They said, what is the bearing of Q from P? Which means we are reading bearing of Q from this guy. So we are taking the reading from this guy. So if you are not watched my video on reverse bearing, go and watch that, because this actually will give you knowledge on it. It's like saying we rubbed this place off and they gave us something like this. That's how it is. So this is 90 degree. Since it is this place we want to read, so I'm going to say that I'm looking for this place. I will call this place theta. That is the place I'm looking for. Don't let it look complicated. Remember, this theta is not here again, it is now here. That's why I said the opposite of this theta is where we call opposite. So if I should say that where is my opposite, this will be my opposite and this will be my hypotenuse. Since the right angle is here, this will be my hypotenuse, this will be my adjacent. And we know that, okay, from point R to point Q, they have said that it is 7 meter. Let me put that there. So that is 7 meter and we are looking for theta. So we can use SOHCAHTOA, anyone. But which one are we going to use? We were given opposite, right? This is opposite. This is hypotenuse. And this is adjacent. Since this is adjacent and we were given opposite, you see, we were given opposite and adjacent. So which one are we going to use? Which is TOA, opposite and adjacent, which is tan theta, opposite over adjacent. So that's what we are now going to use. Tan theta, remember they don't give us theta, it's theta we are looking for, equals to opposite, which is our 7, over adjacent, which is what? Our 24 meter. And you will punch your calculator, you will now divide this 7 over 24. 7 over 24 on calculator is 0.2916666, and you approximate to the nearest. Just make sure it is number like 4 decimal place. After that, you will now, we are looking for theta, not tan theta. We will now bring this one to the other side, and you know that when you bring this one, it will become the inverse of this guy. So theta equals to tan inverse of 0.2917. If you should press that in calculator, let's see what we get. 16.26. Okay, I'll just approximate it to 16.26. But if they should tell you to the nearest degree, so you just approximate it to the nearest degree to be what? 16 degree. So that is the degree that is here. But that is not your answer. Please take note. That is the degree that is here. Remember, they said what is the bearing of Q from P, and what you are checking is that you will start from north till where this line stops you, and where this line stops you is here, and here inside there is 16 degree. Outside there will be what? That's the question now. What will be the value of outside there? Remember, from this guy to this guy is 90 degree. So here will be 90 minus 16, which will give you 74 degree. And that is not also your answer. Remember, you are starting from this point north till this point, and from here to this place is 90 degree. No, not to east, is 90 plus 74, it is now what? 164 degree. So if the correct answer is now 164 degree. If they ask you what is the bearing of Q from P to the nearest whole number, the answer is what? 164 degree. And if you want to make it your compass bearing, it will be what? South 16 degree east. If you have not watched my video on compass bearing, go and check it out. And this is how you solve questions on this. You see, it's very easy, it's not hard. Let's move to the question 2, and this is the second question on bearing and distance. Seeing this question, you may think it is complicated, but it is not. What I just advise you is that whenever you see any math problem like this, don't think it is complicated. Just make sure you start from somewhere. Read and understand. Read and interpret one after the other. Don't just jump into it, or you want to do it rush. Don't rush yourself. Nobody is chasing you. So you can just do it from one point to another. And now let's go. They said X is a point due east of point Y, which means X is on point Y due east. Those key points, be noting them. But I'm going to draw Y now, so that I can know where to draw Y. Okay, let me just draw Y. So let's assume this is Y. Remember, you start from the middle of your nose, because I don't have enough space. That's why I'm drawing it here. So Y, X is due east of this point Y. So this is the east of Y. So you draw it like this. So another x is here. You can see now x is due east of this y. Now z is another point on the coast, but 6√3 kilometer due south of y also. This is y. So they said due south, this is south, so it is going downward, and they said it is 6√3 kilometer. So I'm going to draw it downward. This is another point z, which is for our, but this distance is what? 6√3 kilometer. Remember what they said? They said z is another point on this coast, but 6√3 due south of point y. You can see now, that's how you interpret. So if the distance xz, where is xz? X and z, oh, we have not joined them together. That is where you take your ruler from this point to this point. You will find a line, you just join them together. So when you join them together, this is now the line xz. Remember I told you it will always form a triangle. It can either be a right angle triangle or a normal triangle, maybe isosceles, scaling, whatever that it is. So it is now what? It is on this side. So xz is now what? They said xz is 12 kilometer. So the distance here is what? 12 kilometer. Calculate the bearing of z from x. So this is the x, this is z. We are calculating this the bearing of this guy from x. So we are checking this side. So the angle we'll be looking for will be inside this place. Can you see that now? Remember, this is the guy we are looking, bearing of z from this guy. So we are putting the theta inside this place so that we can calculate this place. Remember, this is the place we are calculating from north of this x till this point whereby the line cuts x and z. That is where we are going to calculate. So here is the angle we are looking for, but we ought to check this one first. Let's calculate what this is. Who can now tell me, is this right angle triangle or other types of triangle? You can see that this place is right angled. You can see that now. So this is a right angle triangle because this is east, this is south, and east and south, these have the distance between east and south is 90 degrees. So this is the right angle. So here, facing here is our hypotenuse. That's why I said if you look if you are looking for the longest side, you may be confused because you may say that, oh, maybe this one is the longest side. But the point is that where this right angle is facing is the longest side, which is your hypotenuse. So this is the key point of the hypotenuse, not actually the longest side, but the hypotenuse is also the longest side on the triangle. Now this is the longest side. This is the theta we are looking for. Opposite of this guy is the opposite, while the other part here is the adjacent. So adjacent can mix, it can be up or down. You remember our adjacent was down and our opposite was not like that. Now let's now calculate for this theta. How do we calculate? Remember, if it is right angle, you can either use this Pythagoras theorem or you use SOHCAHTOA, either of the two. Now I'm going to use, remember there is theta, I'm going to use SOHCAHTOA. But which one am I using? Am I using sine, cos, or tan? Which one am I using? If you should look at it very well, this is your theta. You were given this opposite and you were given this hypotenuse. Abi, opposite is 6√3, hypotenuse is 12. So which one are you going to use? And where which one have opposite that you were given and hypotenuse that you were given? And we should look at it very well. It is only sine that have opposite and hypotenuse, but cos has adjacent and hypotenuse, tan have opposite and adjacent. It is only sine that has opposite and hypotenuse. So I'm going to use sine. So I will write sine theta, because I'm looking for theta, equals to opposite. What's our opposite? 6√3 over hypotenuse, which is our 12 kilometer. Then you cut. You know, I can cut like this. Gone 6 here 1, 6 here 2. So you say that sine theta equals to √3 over 2. Bringing this to the other side, you have theta equals to sine inverse. Remember, if you are taking sine to the other side, it becomes the inverse of that sine. Sine inverse of √3 over 2. What is now sine inverse of √3 over 2? That one I will discuss it better in trigonometry video, how to know the sign of special angles. Actually, sine inverse of 3 over 2 is 60. So you don't need to even use calculator in this one. You can just use the trigonometry ratio that I will soon teach. But if you want it, you can comment it below. I will give you the trick how I use my left hand rule to determine all these angles, or I use my table rule. Anyone? Let's see. Okay, sine inverse of 3/2 is what? 60 degree. Now we just found here to be 60 degree. Remember, that is not our that's not the bearing of z from y. The bearing of z from y is coming from this knot to this point, and this is 60. Now from here to here is 90, to here is 180, so we have 180 now. But from here to here is what we don't know. So how can we get that? Remember, from here to here is 90, like all this place like this 90. So if this place is 60, this place will be 30, because 60 plus 30 is 90, which is this place like this. Okay, now 30 plus 180, what will it give us? It will now give us 210, which means the bearing of z from y is what? Is 210 degree. That's how you check that. And if you want to use compass bearing, which I have explained before in my previous video, I can say that it is what? South 30 degree west. So you can say that it's what? South 30 degree west. These are the two answers for these questions. So let's move to the question 3, where you'll be solving a complex bearing. But don't panic, it is easy. Do you understand? This is the third question I'll be taking on bearing and distance, and this will be the last question I'll be taking in this video. So if you have any questions on bearing and distance that you don't understand how to interpret it, I will drop a link of my WhatsApp group under this description. So check the description and join the link and send it to the group, and we will get to you and send the answer as fast as I can. So let's go and solve this question. Now let's interpret. They say y is 60 kilometers away from x. You will see what they say, but it doesn't end. And they say that on a bearing of 135 degrees, you see that they have given us the bearing of this guy, and they said it is what? Y is what? 60 kilometers away from x. But let's keep this first. We know that we are drawing y, we are drawing x, and we are drawing for y on x. So on a bearing of 135, now let me draw x now. Okay, let me assume this is my x, and they say that y is 135 of x. So where is 135? If you want to not watch my video on 3-digit bearing, go and check that. That's how I explain how to interpret this on this. You can see everything is useful. So where is 135? 135 will fall under here. You know, from here to here is 90, from here to here is 180. So it will fall under here actually. So it will now go like this. Are you getting my point now? Yes. Now here to here is 135, and you are drawing for y. Remember, they said is 60 kilometers. So here is 60 kilometers. Aha. Now they now say that z, you can see this full stop. Z is 80 kilometers away from x on the bearing of 225. Where is our x? This is our x. And they said away from x on the bearing of 225. You can see this 225. So this is this is the place that 225 will fall under. Let me erase this place and put it there. You see the reason why I always tell you that you're drawing your bearing at the middle. You can see now how do I want to draw my 80 kilometers, but I will manage the space because I don't have much space. So let me manage it. So they say that z is 80 kilometers away from x. So I'm going to draw a z now away from x on a bearing of 225. Now from here to here is 180. To this place is 270. But 225 will fall under here. So I'm going to draw something like this. But I ought to let it to be longer, but I will rub it off now and redraw it. Okay, you can see now. I want to redraw them now. I've redrawn only just x. Now they said it is y is 60 kilometers away from x on a bearing of 135. You can see from here to this place is 135. Okay, if from here to here is 90, like this is 90, what will be here? Remember they said is 135, and from here to here is 135. So we do 135 minus 90, which will give us 45 degree. So which means this place is 45 degree. Can you see now? So 90 plus 45 is 135, which is what they say here, this place. And the question says that z is 80 kilometers away from x on a bearing of 225. 225 now, I'm going to draw it like this, but they said 80, so it must be longer than this. You can see now. So I will now draw my Z like this, 80 kilometer. You can see, but they said 225. So let me now mark the angle. From here to here is 180. Remember, from here to here is 90. From here to here is also 90. So from here to here is 180. So 225 minus 180 also will give me 45, which is this place. This, you can see the line. Oh, please don't make the mistake. From here to here is 80. This place is 45 degrees. Are you getting it now? So with this point, we can get the inner part here. So this place is 45. Remember, here to here is 90. So if this place is 45, here will be what? 90 minus 45, which is also 45. We should add this place together. This gives you 90 degrees. I will just put the sign of 90 degrees here. Remember, the sharp edge shows that it is 90 degrees. The curved one shows that it's not 90 degrees. Maybe it's greater or less than 90 degrees. That's the curved one shows. But the sharp one, the one that have angle, means that it is 90 degrees. So I'm not going to write 90, or if you want to write, you can put it. It's still the same thing, which means here is 90 degrees. Now here is 80, here is 60. So I'm going to join this and this together. So you place your ruler and you join these two lines together. So when you join them together like this, it will look like something like this, and that is what you will draw. You have drawn the diagram like that. Now let's now go. They say that find the distance of Z from Y. This is Z, this is Y. They say you should look for distance of Z from Y. So here is where we are looking for. Let me call this place X. I will solve A before I move to B. So let me call this place X. So if I should call this place X, how can I get this X? Although I can use Pythagoras theorem, since this is 90. But first question, second question, I use Pythagoras theorem. Why didn't I use this? But I'm going to use either of this now. So you should follow me and see how we use this and this. Now, we are looking for X, right? We have this place to be 90. We have this. I can use cosine rule. Cosine rule says that X square, right? Okay, from that place, which is A. Okay, if I should compare, my A is now this place. My small letter A is now X that I'm looking for. My 60 is B. My 80 is C. I can use this one, which says that A squared, which is our X squared. So it can be X squared equals to B squared, which is this place, B squared, plus C squared, which is this place, 80 squared. B squared is 60 squared. So it's 60 squared plus C squared, which is 80 squared, minus 2 BC is what? 60, 80 cos A. Our A is what? 90. 45 plus 45 is 90. So our A is 90 degrees. X square equals to, what is our 60 square? 60 square is 36,000 and 80 square is 64,000. 6,400 rather, and 3,400 minus this times this. This times this is 480 times this. So 9600 cos. We can see what I did there. What I did is just that I multiplied this, like 60 square is 3,600, 80 square is 6,400 minus 2 times 60 is 120, and 120 times 80 is 9,600. You can see that like that. And cos 90 is cos 90 here. But what is cos 90? According to trigonometry, cos 90 is 1. Now let me impute it. I will have x squared equals to, this give me 10,000. If I'm not wrong, it will give me 10,000. 960. Cos 90 is 0. So I can actually multiply together. So this gives me 1,000. Cos 90 is 0. 0 times any number is 0. So I'm going to ignore that part. So my x. Now let me go to this place for the x. What will be my x? Now you know I'm taking the square root of both sides. So square root of x squared equals to square root of 10,000. So x square root, we cancel square. X equals to square root of 10,000 is what? Is 100. So my x is actually what? 100 kilometer, which is the distance of z from y is what? 100 kilometer. So if I should, okay, let me put it here, 100 kilometer. And let's move to the second question. The second question says the bearing of Z from Y. What is the bearing of Z from Y? Okay, the bearing of Z from Y. Remember, this is Z from Y. So I'm going to find this angle, this total angle now. Okay, let me now draw this place very well. So I'm going to find this total angle. I'm looking for this angle here, like that, because it said bearing of Z from Y. So we are checking from Y. So we will start from north till where this line stop us, and this line is for Z. You can see it goes to Z. So where this line stop us is what we are going to look for, which means from here to here we bear our bearing for Z, but we don't know this. Let's find this place first. Now we have 90 degree here. We don't know this place, but we have this place. Let me call this place theta. I can actually use sine rule also, saying I have two angles. Because I'm looking for one, I have one. I have the three sides, so I can use two sides and two angles, which is sine rule. You can use that one also. So how do I make it? Remember, sine A over A, sine A over A must be equal to sine B over B, equals to sine B over B. So that's what I'm going to use. Since I don't have this, I'm not going to use this. So it will be sine 90 over, my A is 100, equals to sine theta over my B is what? 80. We can see how it's work like that, 80 kilometer. So sine 90 is actually 1 over 100 equals to sine theta over 80. I can cross multiply, and if I should cross multiply here, 80 times 1 will be 80, 100 times this will be 100 sine theta. So I can divide both sides by 100. So if I should divide both sides by 100, it will become 80 over 100, 100 sine theta over 100. 100 will cancel 100, 0 cancel 0. This for 2 here 4, 2 here 5. So 4 over 5 equals to sine theta. So this 4 over 5, you should punch it in the calculator, it will give you 0.8 equals to sine theta. But you are looking for theta. What is now your theta? So you are going to make theta the subject of the formula. So bringing this one here. So we have sine inverse of 0.8 equals to theta. What is now sine inverse of 0.8? How can you get sine inverse of 0.8? That's when you use your calculator. Theta equals to 53.1. So I can approximate it to 53 degrees so that I won't make any mistake. So that's not what they say we should look for. They say that we should look for the bearing from this guy to this guy. So how can I get that? But listen and listen attentively. We get this. But how can we now get from here to here when we get here to be 53 degrees? You can see that it may look complicated, but it's not complicated. Remember what I told you about alternate angle. This 45 must be equal to this 45. Remember, this is the line. This 45 must be equal to this 45. And once you get this 45, you will subtract from this guy to get here. And getting here, you can find out this place. So this 45 must be equal to this 45. So this place will be 45 degrees. Are you getting it now? Remember, all this place is 53. What will now be this smaller part, which it will be 53 minus 45. So what is 53 minus 45? That is actually 8. So here, this place is 8 degrees. This small part is 8 degrees. So how can we now get the bearing from here to here? Remember, from here to here is 180. So it will be what? 180 degree plus. Remember, this place is 180. But what is this smaller part that remains? That's where you will now subtract 90 from 8. 90 minus 8 is 82. So 180 plus 82 will actually give you 262 degrees. So if you are now looking for the bearing of Z from Y, all this place is now what? 262 degrees. That's how you check bearing. So it is not something like that. Just make sure that whenever you are looking for a question, like a question and you want to solve it, just stare at it and look at it very well. Look closely. Think. Don't let anybody to disturb you. Think, breathe, think deeply so that you can get what they are talking about. And if you can see, you will solve it and you will get your answer. So the option A is what? 100 kilometer. The B is what? see 262 degree. That's how you do bearing and distance. As I've said in the beginning of this video, I said that you should so maybe if you have any questions that you don't understand on bearing and distance, maybe you have solved this several times, you don't understand, or when you solve it, where it's another answer that you are getting, you can drop it in my group link. I have a group that I created for that, so I will drop the link in the description below. Just check the description below and join the group and the channel, and you'll be able to have a lot of experience on how to demystify a lot of topics. So this is the end of today's video. Help us to subscribe, like, share and comment in the section below.